Hello everybody, and I'm very happy here. I'm very happy to be here, and my name is Daniele Pagliero, and I'm a software developer and a musician from Italy. While I feel more comfortable when I play gigs, I find speaking in public very difficult, so please forgive me if I make mistakes. I will do my best to make this presentation enjoyable by you. Some words about Faselunare, my company. Faselunare is the Italian word for moon phase, and it is a small company based in Torino, and it is composed by me, Alessandro, that is an electronic engineer, and he designed the electronics of the instrument, and Francesco, that is a product designer, and is very skilled also in electronics, and it has a deep knowledge of the synth world, and is also an organizer of the Sound Meet, that is a music instrument fair that takes place in Italy every year. And me, that I am a software designer and a musician, that my job here is making firmwares. We design together the instruments, and our flow is to iterate over the prototypes. So we do a basic hardware prototypes, and then we code a minimal firmware, and then we make some tests. We collect feedbacks from us and also from our tester friends, and then we start again. Right now we are working on two projects that are, one is the Microcosmos, the one I will show you today, and the other one is a Vega, that is a modular Eurorack drum machine. They are in the same stage, they are advanced prototypes, and they share very similar hardware and firmware. We exist since two years, and we are working on a business plan to find fundings to release those products next year. And also, we presented them on the Superbot in Berlin on September, and we have some distributor contacts. Okay, let me briefly introduce you the contents of this presentation. So the first thing is what is and why we did the Microcosmos. So this board right here. And I will give you an overview of the Microcosmos features with some audio and video demos. And then I will show you the hardware and the architecture of the software of the Microcosmos. And then I will show you where you can find the open source temporary repository. And then I will show you the tools for programming on the Microcosmos and the workflow so far on how to program the Microcosmos. And then I will show you a final video demo of what we can code using Faust, and then the further developments and Q&A session at the end. I have some questions for you to know to know the audience. So can I ask you how many people have used Arduino or Teensy before? So please, can you raise your hand? I cannot see you, you are very small, but okay, there's a lot of them, okay. And also, okay, and how many people have knowledge or have programmed with the Faust language before? Oh, nice, okay. Okay, so you know what I'm talking about, basically. And of course, there's another question, but it is not so important right now. Okay, I can show you, sorry. The third question is how many people know about Pure Data or MaxMSP or Super Collider or other audio programming environments. Okay, that's fine. Thank you. Okay. Microcosmos, what is and why we did the microcosmos? We started to work on the microcosmos because we want to create a playground for our experimentations on making electronic music and microcontroller programming. It was inspired by other two instruments that we use. The one is the axolotl, that is a board developed by John Stallman, and the Norns by Monomi. What is Microcosmos? Microcosmos is an open source electronic instrument that is aimed at programming electronic musical instrument, and also we did it for learning electronics and microcontroller programming, and of course audio DSP. Microcosmos is made on Teensy 4.1 and has those features. It has encoders, buttons, a TFT display, SD card, MIDI in and output, and MIDI over USB. And the microcosmos can be programmed using Faust. That is a language to create electronic instruments and or effect processors. The key features are that it is a standalone device for running DSP code. It has an UI made of buttons, encoders, and so on. And it also has MIDI functionalities for real-time manipulation. It is easy to program with a standard developing tool that is quite common, that is Arduino, that is basically the same as the Arduino environment, if you know it. And using the Faust language, you can design the audio DSP part. The most important thing is that we can test DSP code on computer before uploading to the board. That's why we choose Faust, because it has a web editor that you can use to test your audio DSP code, and then you can load on the board. So the state of the project, we worked on it for 2 years, and we did 3 hardware revisions so far. And this is an advanced prototype, and new hardware is on the way. So we are working on a new version of it. But maybe you know that there is this global short gauge of electronic parts. So, and that's why we are a bit late to finish it. So we have to wait a lot to get all the components we need to build new version of the board. And another thing we are working on is to make a custom tools like an editor or a librarian to make it more easy to program. And the picture shown here are the previous version of the board. So the last one is the very first one, and then some renderings. Now I can show you a video about how it sounds. Just wait a second that I will show. Don't expect any high fidelity stuffs. It's more like noises and glitches. that's it. I hope you enjoyed them. Also, if the audio quality is not very good, and also the material was very ugly in a way, but it's just to give you an idea that you can do different kind of instruments, drone machine or looper, I mean effect or something like that, and also a standard subductive synthesizer. So that's the point of those videos. About the hardware of the Microcosmos. Microcosmos is based on the TNC 4.1, that is a USB-based microcontroller development system, very similar to Arduino, but more powerful. In fact, the thing is that it is an ARM Cortex M7 at 600 megahertz. It is compatible with Arduino software and libraries, and there are many development tools that can be used, and works with macOS, Linux, and Windows. And it is you can upload your firmware by USB like the Arduino, and it is very tiny, so it can fit the project. And about the hardware, we have the 16 RGB LED and 1 RGB for the power, and to show that the board is on or off. 1 TFT display, 5 RGB encoders with buttons, and 5 push buttons. There's a lot of connection also. We have audio in and out, headphones out, an internal mic, an internal microphone that you can use to sample maybe. It has a USB host. Then it has MIDI in and out, and a micro SD card reader. About the software, let's start from the hardware access layer. That is the part that contains all the facilities to communicate between the hardware. For instance, it gets the encoder values, send and receive MIDI messages, and turn on and off LEDs and draw on the display. Then on top of it, we have the program logic, that is the place where the behavior of the board is developed. By default, there are 2 programs. One is the boot program that just turn on the board, and the main program that deal with the audio part, and then put in connection the hardware access layer. To do that, we have a mapping file where every parameters of the DSP audio code are mapped to the control of the board. And then there is of course, the audio part that is made with Faust, and it is based on the TNC audio library. Okay, this is the link for the open source temporary repository. It is not the official one, so you can download and you can see the examples I showed you in the previous videos of the patches we used on the board, so you can download and see them. But it's not the final version, let me say, because we will publish officially when also the board will be ready and available. Okay, the tools for programming the microcosmos. As I said before, there are two tools needed to program the microcosmos. One is the TNC Duino, that is a software add-on for the Arduino to run sketches on the TNC. And you know that most program written for Arduino works also on TNC. So basically Arduino and TNC Duino are the same, and you program it in basically the same way. And then the Faust, that is a programming language to develop audio programs. It was made at the Graham Institute in Lyon, in France. It is functional programming, so that means that you have to compose function in various ways to create the final program. And you have to consider that a function is a signal processor. That means that a function has an input stream, then it changes the stream inside of it, and then output the stream to the next function. Another important thing is that can be exported to many platforms. That is the second reason why we choose Faust to for our board, because it exports directly for the TNC platform, so it's very easy to integrate in our project. And if you don't know it, I suggest you to take a look at the tutorial on the link, because it is very clear and well written to understand how this language works. So, this is how the Faust web editor looks like. So you have and you have to code it like any other language editor, and then when you run, you can see the user interface of the various controller you are programming. So the workflow for making an instrument of the microcosmos is based on 4 steps. The first one is to create an audio DSP code using Faust on the web editor, and then play with it. And then when you are satisfied by it, you can export it with the Faust exporter of the web editor. And then you have to put on the firmware folder to compile it and then put on the board. But before, you have to map the parameters to the UI. If, for instance, if you have a cutoff control of your synth, and you want to assign to, let me say, this encoder here, you have to map this behavior on a map file that do this for making it for communicate between them. And then the last part, of course, is compiling and upload the new firmware on the device. Okay, so the first part is programming with Faust. So I have to, I can share my screen to see a very easy program done with Faust, so you can have an idea of how programming with Faust is. Can you see my screen? I have also to share my audio. I think I have. Let me do a very quick test. Can you hear it?
Yep.
Okay. This is a very basic Faust script to make an oscillator. So basically, what we have here is this pulse train object that is a square wave oscillator, and then we pass its frequency and sorry, I don't remember in English how to say the sorry. The period, I'm very sorry. And then when you have this function, that is the oscillator function, you can output it by, of course, diminishing the volume a lot for not breaking your ears, and then with this composition operator pass to the stereo output of the program. So what we have here is this sample here. So you can hear the square wave. Okay. If you wanted to not to use the hertz, the frequency, but if you want to use the a MIDI note to control the pitch, there is a function that is the MIDI key to hertz, that you can pass a note that in the range of the MIDI note, so 1 to 126, and you can transform it in a frequency. So in this case, this example is the same as the one before, but the pitch is now coming from a note that is converted to hertz before going to the pulse train. So we have exactly the same, but passing the note. This is important because on the next example, we have this note parameter. So let me introduce the UI parameters. So you can change a variable in the Faust program using this UI interface. In this case, we have a slider that will control the note, and then the note will be translated into a frequency pitch and then pass to the pulse train. So the result will be this one. The UI parameters are very important for us because they are the way to mapping them later to the board. So the note parameter will be controlled by the board, by the mapping file. Okay, here I add a gate button, so we can turn on and off the signal. So we have this, and by default for the microcosmos, if you have two parameters, that one is the gate parameter and one is the note, it automatically knows that it can manage it as a MIDI note. So basically, you have the note and gate for controlling the board by a MIDI note. So here is the same as before, but we multiply the volume of the oscillator by the gate, that is always 0 and 1, and then we pass to the output. So again, okay. In the next example, I added a 2-point envelope. Sorry, I go fast because we don't have a lot of time. But if you have any question or curiosity, you can ask me. So I will go on. Here I added a 2-point envelope. So here we have the gate, the node, attack, and release. That are here. Gate, node, attack, and release on the user interface. And those numbers in square brackets means only that this is the order on how they should appear on this interface. And we have this object that is envelope attack release. Then we pass the attack and release variables, and then the gate to start the envelope. And then the rest is the same, but we multiply not for the gate, but for the envelope now. So we have something like that. I can put more release or even attack. Okay, the next one is adding a filter, a low pass filter. So here we have two more parameters, the cutoff and the resonance of the filter. The Faust has many filters. Here I choose the resonator low pass filter. So we have the cutoff and resonance parameters, and then in this case we process the oscillator function that goes to the filter, and that is multiplied by the envelopment value, and then go to the output, just scaling it very down to not break your ears. And here we have the filter, just okay, last part of this tutorial is putting modulation. So in this case, I use an LFO in the shape of a triangle wave, and then I can control it by I can control the frequency by a slider, and then I can control also the cutoff amount and the pitch amount of the modulation. So here I can introduce two new variables, that is the modulated note and the modulated cutoff. So for instance, I take the note and then I multiply the L4 for 24 steps, that basically the note will be modulated by 2 octave. And then for the pitch amount, so the more I add the pitch amount, the more I get the modulated note. And the same is also for the cutoff. So I multiply the L4 for 100 Hertz, and then multiply for the cutoff amount of the modulation. So here and also I will use the pitch, no more the single note, but the modulated note, and for the filter, the modulated cutoff, and no more the cutoff. And so this is how it sounds. Can and okay, and this is for the pitch. Okay, so this is the final script of of what we wanna export to the microcosmos. So this is basically the code we have and we wanna put on the board. So as we are satisfied by it, okay, you have to imagine it. I go back to my slides. Can you see them? Okay. So there is this export window on the editor. So you have to put a file name and then choose the platform that right now is Teensy, but maybe in the future we will have a special exporter for the microcosmos. So we are in touch with the guys of the Faust for asking for more functionality than what we have for just the Teensy. And then you have to just press the download button and copy it on the folder of the project. So the last thing we have to do is the mapping of the parameters. Mapping is basically done with the pages that that is the grouping of parameters to show them on the display, and also to control them by the encoders. So basically we have pages, and then every page has menu items, menu params that are composed by many parameters. So the Faust param name, I mean, you see before the cutoff and resonance and something like that. There is also the facility to display the name, and then you have to put the value of the parameter and the minimum and maximum value, and the control change mapping if you want to control them by an external USB controller or MIDI controller. And then there are also buttons, so you can use them as momentary or toggle or not use them, and they can manage a single parameter, a MIDI note, or the menu up and down, the menu that is shown on the display. Then the last part is uploading the microcosmos new firmware on the board. So you have to switch to the Teensy and then open the project, and the last thing to do is compile and upload on the Teensy the new firmware. So right now I can show you the video of the same patch we have seen on my sharing before. So just wait, I will show you. The final demo. In this case, you will see that it is controlled by an external USB controller. And also you will see that the parameters can be changed by control changes. And I know maybe the screen is very small, but you can see the changing of the parameters on the TFT display. Okay, and that's it. Okay, that's it for the workflow. So, and that's basically it for my presentation. So the last thing I wanna share with you is the further developments of what we are planned or what we wanna do that is not already done. The things, the first thing is that we want to make it more easy to program. So we are working on a custom editor for creating patches and upload them on the board more easily. So reducing the workflow basically in just one step. And another thing that is very important that we want to achieve is that we want to multiple switchable firmwares. So that means that maybe you we want to make possible to upload on the SD card many firmware, and you can switch them by the board itself without using computers. In this case, will be more usable than connecting to the computer and then upload another firmware every time you want that the board behavior in a different way. Of course, we need better hardware implementation for encoders and MIDI. So sometimes we have some glitches, or we want to switch from. Right now, we are using interrupts, but we found out on another project that using polling give us better results. So we want to move also this project to polling parameters instead of using interrupts. We want to also add battery operation mode. So you can put a battery on it and bring it with in your pocket. And then we want to add support for samples, and we want to make it polyphonic. Right now is monophonic. Maybe you can achieve polyphony if you program a Faust in a different way, but it's quite complicated, and we want to make polyphony more easy. And of course, we want to make a community DSP library so people can contribute to create DSP audio code. And that's it. I hope you enjoyed it. And sorry for my English. And right now, if you have any question, I will be very, very happy to answer you.
in your last slide, you were talking about samples. How do you wish to integrate samples in Microcosmos? What's the idea behind that?
Okay, we didn't explore it yet. I have some ideas in my mind. So because Faust can, you can have architecture file with Faust. So you can manage also data stream with this kind of integration by Faust. The difficult part is that you have to deal with a very complicated file system. So you have to know if the files will be on the SD card or maybe in flash RAM or something like that. So it's not very easy right now getting a direction on how to develop it. But for sure, we want to do that.
And I think we had one more question.
Actually, I have two questions. Oh, it looks like a cool tool. I'm wondering if you have any sense of when you'll ship and how much it will cost. So that's question one. And question two is, do you think you have any competitors? Who would your competitors be?
Okay, answering your first question, well, we are discussing, and as I said at the beginning of this presentation, we are working on a business plan to understand how to commercialize them. So we have contact to distributors, but we don't really know yet how will cost. Well, depending of the cost of the materials, I think it will be around 300 euros, something like that. And your second question, I don't remember. Can you please? Sorry.
Do you feel like you have any competitors?
Oh yes. Sorry. Yes, we have in a way. I said that this project was inspired by the I don't want to say competitors. Maybe they are people that want to make similar projects, and the similar projects are the Axolotl, that is a very nice small board without any user interface, just connectivity, and then you have an environment that is like MaxMSP, so you can compose your patches in a graphical way and then upload to the board. And that's one. Well, I use it a lot in my in my music production, so I was inspired from it. And the other one is the Norns by Monomy. That is a very beautiful instrument, and also that one you can program your patches. I think you can use pure data or other languages like that, and the workflow is pretty similar. You can upload new firmwares on the boards, and then you can use that. I think we are. Speaking about commerciality of this product, we are in the midway, because the Norns is a very expensive board, while the Axolotl is a very cheap one. So we can fit in the middle.